Welcome AP Chem students. This is Mamit, Cindy, and Michelle, and we're doing our video on solubility with the KSP. So this is a sample question you could be given. What is the solubility when calcium carbonate is dissolved in water? So what is solubility? Solubility is basically how much of calcium carbonate can be dissolved in a solution before the solution is saturated. So we are given the KSP, which is 3.8 times 10 to the minus 9, and let's get started. So the first step is to write the dissociation reaction, which is a reaction that outlines the dissociation process of calcium carbonate. So this is how you write it. You start with calcium carbonate, which is the solid, and it's dissociating, meaning it's dissociating in water, into calcium 2 plus, the cation, plus carbonate 2 minus, the anion. So once you've written the dissociation reaction, which you should know already how to write, you set up, number 2, the ice table. This is how you set up the ice table. You draw a line through calcium carbonate. We're not going to be counting calcium carbonate. Why? Because it's a solid, and solids are not counted in KSP. So, and then next, we're going to put a 0 with calcium 2 plus and carbonate 2 minus. Why? Because this is a product side and we have not made any products. So we're starting with 0 moles of Ca2 plus, and we're starting with 0 moles of CO3 2 minus. And then we're going to be adding x's to both sides. So it's plus x with the calcium 2 plus and plus x with the CO3. Why is it plus x? Because we do not know exactly how much is actually going to be formed after we dissociate. Because the ratio is a 1-to-1, there's no coefficient in front of the calcium 2 plus, and neither is there any coefficient in front of the carbonate. This is a plus 1x and a plus 1x. So 0 plus x is x, and 0 plus x is x. So the third step is, so we have our ice table set up. The third step is to write the KSP. So if you do not know what the KSP is, which you should know, AP Chem students, KSP is basically you're taking the reactants and you're putting it over the product. So it's reactants divided by the products. However, in this case, the reactant is a solid, so the solid is not counted in our KSP. So if we're looking at it, KSP equals to the concentration of calcium 2 plus, the cation, times the concentration of CO3 2 minus. So let's get started. We know what our KSP is. What is it? It's indicated, it's given, 3.8 times 10 to the minus 9 equals to, what's the concentration of Ca2 plus? Oh, we just figured it out up here. 0 plus x equals x. We have x amount of calcium 2 plus times CO3, the concentration of carbonate, which we figured out is also x. X times x equals to x squared equals to 3.8 times 10 to the minus 9. So the solubility of this would be basically what x is. So you take the square root to cancel out the square. X equals to, so after we square root 3.8 times 10 to the minus 9, we get 6.16 times 10 to the minus 5 equals to x. This is our solubility. The answer to the question, what is the solubility, is 6.6 times 10 to the minus 5, which means that this is the amount of calcium carbonate that we can dissolve in a given solution of water before the solution is saturated.
So the next question is, if the concentration of F minus is 2.54 times 10 to the negative 3 molars in a calcium fluoride solution, what is the KSP? So the first step you should take is to write the dissociation reaction, which will be this. And after you write out the dissociation reaction, we should always use the ice table. So the next step you should take is to draw the ice table. So since calcium fluoride is a solid, it doesn't react in the reaction, or it doesn't count. And so you only write out the aqueous, and the aqueous for the fluoride is given, which is 2.54 times 10 to the negative 3. And since it's 2x, when you divide it by 2, it should be 1.27 times 10 to the negative 3. And so after you draw the ice table, we should always write the KSP. So the KSP, the formula for the KSP should only be the products over reactants. And since the reactant is a solid, you can't write it in the KSP formula. So when we substitute all of the numbers in, the outcome should be 8.19 times 10 to the negative 9.